Solving inequalities. The first thing you need to know for inequalities are these signs. Do you see the word equal? Inequalities are the greater than and less thans. This right here, this sign, is a less than. This sign right here is a greater than. I'll show you how to decipher between the two in a little bit. But this is a less than. It looks like an L. Can you kind of see L there? This is a greater than. Now, what does this line underneath mean? It is the same symbol as this one. It just has a line underneath. Whenever you put a line underneath the less than sign, it ends up being a less than or equal to. Less than or equal to. Now, aren't these two symbols the same besides the line underneath? This one is a greater than or equal to. So, this is just saying a little bit more. It's greater than and it's equal to. This is saying this one here is saying it's less than and or it's equal to. So it's just a little bit more with this line underneath. It's kind of like an equal sign and a less than sign squished together. Okay, over here. Why do I have a number line here? You should know negatives are this way, positives are this way. What do you see right there? Look at my finger. What's that sign? Greater than. What do you see right there? Do you see a greater than sign? Look over here. Look right here. What do you see right there? Isn't that this sign? Isn't that a less than sign? Anybody ever notice that? A less than sign right there. Greater than sign right there. Now look at this number line. Does it make sense? This is the greater side of your number line, and this is the lesser side of your number line. So isn't the lesser sign on the lesser side of the number line? And the greater than sign is on the greater side of your number line? That is a very good way to remember the two. The less than sign's on the lesser side. The greater than sign is on the greater side of the number line. The other method I use for a lot of people is the less than sign looks like an L. That's the greater than sign's the other one. Anywho, when solving inequalities, these are all inequalities. What you do, there's an extra step. You solve them just like equal signs, but there's one extra step. When you are solving inequalities, if you multiply or divide both sides by a negative, this is a rule. When you're solving inequalities, if you multiply or divide both sides by a negative, then what do you do with the inequality sign? You flip the inequality sign. Now, see all these inequality signs here? When you're solving the problem, if at any point you multiply or divide both sides by a negative, the inequality sign flips. Otherwise, you treat it just like an equal sign. It's pretty cool. It's actually the identical thing to Chapter 2. Just one extra step. So, on number 1, if I want to solve this, I treat it like an equal sign. So I want to get the x by itself. So how do I get rid of a negative 8? Well, I add 8 to both sides. When I add 8 to both sides, I now have x over here. That cancels. And I have a 12 over here. Now, did I multiply or divide a negative? No, I just added 8 to both sides. So the sign stays. There's your answer. Okay. Number 2. I want to solve this. How do you get the negative 3 off the end? You divide. It's held by my multiply, so you divide by negative 3. That cancels, leaving you in. And what's 21 divided by negative 3? Negative 7. Now, Did I multiply or divide both sides by negative? Yes, I just did. So what's going to happen to this sign? It flips. It is now a greater than or equal to. We'll come back and describe what this are and make graphs in a second. Number 3, sorry. I want to solve for A. How do you get this 2 off the A? Well, the 2 is divided from the A, so the opposite of divide is multiply. So it looks like I'm going to multiply both sides by 2. Cancel that. I get A. Over here I get negative 14. And did I multiply or divide by a negative? No. I didn't divide or multiply by a negative. That is a negative, but I didn't multiply or divide both sides by a negative. So the sign does not flip. It stays. Number 4. I want to get B by itself. So the first thing would, to get the B by itself, you first actually need to move the 4 over. So minus the 4 over. I now have negative 2b is greater than or equal to, and negative 10 minus 14 is, negative 10 minus 4 is negative 14. Okay. Then I divide by what to get the b by itself? I have to divide by negative 2. Oh, doesn't that cancel? This negative 14 divided by negative 2 is positive 7. Did I divide or multiply by a negative? I divided by a negative, so my sign was a greater than or equal to. Now it's less than or equal to. Now, what does all that mean? What this means is any value less than 12 makes this statement true. What is a number less than 12? 6. Does 6 minus 8 gives you negative 2? Is negative 2 less than 4? Yes. Any number less than 12, when I plug it in, will work. There's a whole bunch of answers. But anything less than 12. Here's how I would graph that. If that's 0 right there, and this is 12. Got it? On a number line. 12 is not part of my answer, because does this say less than or equal to 12? No, it says less than 12. So I leave an open circle. Now, which side of the number line are the values less than 12? Sorry, which side of that dot are values less than 12? Left. So what I do is I shade the side left of it. That is saying, that is a picture showing me all values to the left of 12 or less than 12 are true. Any number over here you plug into this equation will work, except 12. That's why it's open. This one. Yes, you want to draw them. Put negative 7 here, because that's the number given. Now, if that's negative 7, is that an open or closed circle? Well, it's closed. Or equal to, so I fill in the circle because or equal to means that's part of my answer. And this is greater than or equal to negative 7. So which side of the line of this dot is greater than or equal to 7? Right. Negative 7. It is this way. Is that true? Are all those green values greater than or equal to negative 7? Yes. So it's solid whole because or equal to, and everything this way is shaded. This is a picture of all the values that work. Now, by the way, look at this arrow. Isn't that arrow pointing this way? Wasn't that arrow pointing that way? It always points to the direction you want to go. Very helpful. Here's 0. Do you guys like how I just put numbers and don't have to worry about all the dashes? I'm not big on all the dashes. It just takes more time than needed. Open or closed circle for number 3? Open. It's just greater than, so it's an open circle. And which way does the arrow point? Right. To the right. And doesn't that mean greater? Isn't this side greater? Follow the arrow, pointing greater. And the last one. It's a closed circle because it's or equal to, and it says less than or equal to. Which side's less than or equal to? The left side. Follow the arrow. Aren't all these values on this side of that dot less than 7? Less than or equal to 7? Okay. again, what this answer means is any number I shaded, meaning 6, 5, 4, 3, 2, 1, negative 20, negative a million, all those answers, if I plug them in for B, it'll make the statement true. Anything to the right over here, 8, 9, 10, 11, 12, those would make this statement false.